GM, everybody. Welcome to what's going to be another great DevNTell. So if you didn't know, DevNTell is a 30-minute podcast for builders to showcase something they have been building or are passionate about. And today I'm ecstatic to have on Daniel Porteous, who's an engineer at Aptos Labs, who's going to give us an overview of Aptos Move. So if you didn't know, Aptos Move is a next-gen language for secure, sandboxed, and formally verified programming, which is used for multiple chains. Move allows developers to write programs that flexibly manage and transfer assets while providing security and protections against attacks on those assets. So if you stick around for today's session, you'll learn about Aptos Move, how it differs from other smart contract languages, and how it makes for a delightful development experience. All right, let's get into it. GM, welcome to the show, Daniel. Happy to have you on, man.
Thank you. Yeah, it's good to be here.
Yeah, excellent. So I guess before we get into all the fun stuff, do you want to give a brief introduction about yourself?
Yeah. I'm Daniel. I'm a software engineer at Aptos Labs. I've been around in Aptos Labs since April 2022, so pretty early days, pre-mainnet. And I guess in my time there, I've worn a lot of different hats. So I was like a production engineer when I actually first joined. And since then, I've sort of bounced around between working on developer platform stuff, developer relations, infrastructure on things like APIs, tooling, the Move language, of course, indexing, and things like that. So I guess I'm a bit of a generalist at Aptos Labs, I guess.
Excellent. And what kind of brought you to Aptos and Web3 in general? I'm always curious to hear what brought people into the industry.
Yeah. So when I joined Aptos, I was like a complete Web3 noob. So I knew very, very little about it besides like occasionally trading. I think I was into Ripple once upon a time, way back in the day. But yeah, from a tech perspective, I didn't know too much. But I was interested in the project back in its pre-Aptos origins when Meta, or Facebook at the time, was working on it. And I thought the idea of a low-cost/no-cost cross-border payment network was like a really great idea. Like I hate to see people get like gouged on remittance payments and stuff like that. So just even that basic use case of like peer-to-peer payments really brought me in. And then, well, since then, it turns out blockchains can do much, much more than that.
Awesome. Love it. Yeah, I guess I know you have quite a bit packed in for us today, so let's get right into it.
Great.
Bring up your slides here. And for those of you watching, if you have any questions for Daniel as we go along, please type those out and we will bring them up as we go. All right, go for it, Daniel.
Sweet, thank you. So yeah, today I'm going to be talking about Aptos Move specifically. I'll intro us with like a brief intro into Aptos tech more broadly, like the core of the blockchain and some of the platform that we provide, before diving into Move itself. And we're going to be going through like I'm going to assume the audience has some familiarity with blockchain in general, but maybe not Aptos Move. So we're going to be going at Move from like a very introductory level, I suppose, and then we'll like allude to some of the more advanced concepts later on. So starting off with just some of the Aptos tech. Aptos is a layer 1 blockchain that provides like a lot of good characteristics for building smart contracts and applications or whatever it is you want to build on top of Aptos. We have tested sub-second latency with true finality. So no waiting some number of blocks with the hope that your transactions will be committed. Like we have instant finality. A lot of the things you want to use on Aptos are part of the core framework. So there's no need to go out and worry about like, am I using the correct standard for tokens or for coins or something like that? There's like one standard for each of these things built into the framework, ready to go. Contracts are upgradable. So no longer do you need to have things like proxy patterns where you upgrade your contracts behind some proxy contract or anything like that. There are different granular levels of upgradability that we support depending on your needs with your smart contracts. So like Aptos in sort of recent history, we've got a lot of like nice, good, big numbers, like 150 million transactions in a day. I think this is actually old. We've exceeded that since then. Like I said, less than 1 second time to finality. Gas is very cheap, but we do have a gas fee market for times when there is contention on the network. And in recent times, we've been trying to improve the user experience with things like passkeys and social login, web-based wallets, things like that for onboarding, the next billion users from Web 2. But we've got all of these like nice features and stuff that we supply, but is it easy for you as a developer to actually like make anything on Aptos? That's the question. So we are obviously working on that to try and make it easier and easier every day. Nodes, for example, are free. Like if you're building on Ethereum or something, there's no sort of core mainline node for you to go to. You have to go to Infura or Alchemy or something like that. We provide nodes out of the box that people can access for like our node APIs, our indexing, all of that kind of thing. And we also have an ecosystem of people providing nodes with higher rate limits, specific use cases, etc. We've got like a robust selection of different SDKs. Obviously, everyone in Web3 likes to develop with TypeScript, but there are people out there who prefer building their dApps in other languages. So this is just a selection of some of the toolkits that we have for building with, and we're adding more as we go. We're building a Golang one, Unreal, etc., so that you can integrate Aptos with whatever you're building. We've been putting a lot of effort into developer experience lately, like making sure that we're available for the community. We've built out something called Aptos Learn, and I'll have a QR code for that later. Our dev docs, like just last week or the week before, we released like a massive overhaul of those docs so that it should be much easier for you to get the information you need easily. And sort of what I talked about before with like social login. I'm not a cryptography expert, so if you ask me questions about this, my answers may be very high level, but we do have ZK-based social login now for blockchain accounts. The TLDR is, your Google account is your blockchain account, or your Apple account, or whatever. And then talking about Move, we've got a variety of other things that assist you with Move. Like one key feature of the Move language is that it's formally verifiable. No other smart contract language or major language supports this. So like when you're writing your code, you can also write these specs that define attributes of your code that should be formally verified. And we have that all built in, available to you to make sure that your code is as safe as you think it is. As well as other things like Move formatters, IDE plugins, and we just recently released a decompiler as well. So if someone chooses to upload a module on chain, but not include their source code, by design, Move bytecode is decompilable back into source. We support that now as well. So those are just some of the things about like Aptos and like why it's a great development environment. And you might be thinking, okay, so like how do I actually build a dApp on Aptos? This is where Move comes in. So like Move is the smart contract language that was built for these layer 1 blockchains. So we're going to go through just a really simple program, and through this program or this smart contract, it should reveal some of the attributes that make it easy to write Move that does what you think it does in a safe way. So this is like a very simple program we're looking at for defining a coin, a very basic coin. So you've got this struct coin that has some value, some amount or balance or whatever of that coin. And then a withdraw and deposit functions for taking coins from somewhere, depositing them somewhere else. So we'll dive into like certain aspects of this code now. So starting at the very top, this definition here defines the adder here is just like a named shorthand for an address. So in your Move TOML configuration file, this is just an alias for like 0x blah, 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 which is whatever address this module is deployed at. And then coin here is just the name of your module. So the way smart contracts are deployed on Aptos is they're deployed in accounts or objects, just like any other resource. Like we try to put as much of the sort of core blockchain logic, I suppose, into Move and into the framework where possible, and avoid any like special source happening outside of the Move universe, I guess. So with that in mind, modules are also just like resources on chain. Yeah, so like at your address, you could have other modules. Like you've got a coin module, you could have a token module, a chess module, whatever it is you're building. This has thing we're talking about, this is what's called an ability. This allows data to be stored directly on an account. So if I have this struct coin has key, what this means is that on an account, you can have this resource inside it. There are potentially times where you make a resource that you don't want to be able to be stored in someone's account. Maybe they should only be stored inside other resources, for example, in which case you won't have has key. There are other types of abilities. I think one really important aspect of Move is I suppose this is the namesake of Move, is that things are moved by default, very similar to Rust. It's not like copy by default semantics, it's move by default semantics. Because we're modeling things here, right? Like coins should not be copyable, they shouldn't be droppable, and by default, they're not unless you have has copy or has drop, right? So since this coin doesn't have those abilities, it's guaranteed by the compiler and the VM that you can't accidentally lose a coin or you can't accidentally copy a coin, because that would obviously be a huge vulnerability for the model. And all of this is guaranteed like at multiple levels throughout the Move stack. You'll notice that some of these functions here take a signer. A signer is essentially a token, I guess, indicating the caller of the function. So if I, using my account, call this initialize function, account here as the first parameter of the function will be me. You will notice that some functions here do take a signer and some do not. For example, if I want to withdraw coins from an account, I need the permission of the signer to do that, right? No one should be able to just take coins from my account without my permission. Deposit, on the other hand, has no signer. If someone wants to give me money, that's fine by me. And they don't need a signer for that. So as you can see here, only the signer has the permission to add resources to an account with this move to command. And similarly, what I just mentioned with withdraw. There are other things here. Integers by default in Move are unsigned. There is no signed integers at the moment. So it's impossible for you to underflow with this logic. It will just abort. And that's guaranteed. So you can't accidentally like underflow someone's balance to be like 2 billion coins or something. Notably, this deposit function, anyone can call it, but you can only increment the balance of coin on my account if I already have a coin resource. And initialize can only be called by me. So if I don't want people to be able to send some kind of spam coin or something, I have to have initialized receiving that coin type first before someone can deposit that coin to me. And all of this is like obviously configurable. Like maybe based on your application semantics, you do want that behavior, and that's all available to you depending on what code you write. And then finally, this is another big thing, is when a struct is defined in a module, like coin is defined in the coin module, only that module can interact with that struct. So everything that you want to do with that struct must be exposed via functions, right? So like, because I don't expose a function like double my money, where it just takes the balance and 2x's it, no one can do that because no one else can access coin except for this module. So everything's protected within the module in that way. Down the line, we're working on things called public structs, which will work differently, but that's an advanced topic for later.
This is great. Nadev actually has some questions around this slide I think are worth addressing at this point before we lose context.
Right.
So the first one, is the smart contract itself stored in your wallet, address, or account?
Yeah, so the module is actually, yes, it's stored in, I guess you could call it a container. So you can deploy contracts to an account. That's like the default. We also have something called objects, which are like where with like a different ownership model, you can also deploy contracts to those. But yeah, so they're not like on other blockchains, they're sort of a separate, like globally addressable thing with their own storage. That's not how smart contracts work on Aptos. We prefer to store resources in accounts, in objects, in other places, and the models themselves the same way.
Great answer. And then when you mentioned drop, did you mean to say lose? And how does that work if it has a drop, so to speak?
Sure. So let's take this. Which function should I look at here? Deposit, blah, 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 blah. So let's even take the initialize function. So in the initialize function, we have two major things. We create a coin and then we move it into the account, right? You can imagine a version of this function where I instead create the coin and then I don't move it into account. Maybe I do something with it. Maybe I forget to move it into the account. And like I think just by creating it, it'll put it in the account. Once we get to the end of this initialize function, if I haven't moved that coin I created somewhere, that's an error because this coin doesn't implement drop. If it does implement drop, once I get to the end of scope, that's okay because it'll be dropped, but it implements drop and that's fine. If we get to the end of scope and some resource is still lingering in the function scope that doesn't have that ability, that's a compilation error. That's sort of what this means.
Sure. Good answer. Good answer. And then finally, I think you touched on it briefly, but the function move to, what does it exactly do?
Sure. So move to is like so there's also a move from, and move to and move from are to move resources into and out of a container or an account. With this initialize function, you can see that this is a public function. That means it's a function that can be called by code outside of the module. So I could write my own code that will call this initialize function and will then create a coin and move it onto my account. So where is the coin moved? It's moved to the account of the caller. With this, like with the latest stuff around objects and stuff, the caller could also be like this signer could also belong to an object. So it's pretty much whoever calls this initialize function, the coin will be moved into their account. And the account is essentially just a container for resources. From where the coin is just created out of thin air in this case. So in the initialize function, coin is just created, which is the privilege of the coin module because it defined the struct, and then it's moved into the account.
Excellent. We have one more question, but looking at time, do you want to answer the last question on the slide, or you want?
I can answer one more. The rest of it I can breeze through a bit faster.
Sure thing. Killer Tech is just asking for a brief once-over of the withdraw function.
Sure. So this withdrawal function takes two arguments, right? So withdraw takes the signer of the account, so the caller, and then some amount of coins. So essentially what this is doing is it's splitting a coin. So when I go this borrow global mute, this is saying take the coin that exists on the caller's account and we'll get its balance. We then subtract the balance by some amount, right? So let's say they previously had 100, we subtract 50. The balance of the coin remaining in their account will now be 50. We then create a new coin with the remainder amount, the other 50. And this function, as you can see, returns coin. So we'll actually see later that you can compose these two functions together to create a transfer function. So if you just withdraw from one account and you take their signer, they're the sender, you withdraw from them, get that coin, and then you deposit that coin into the receiver's account, you've just created a transfer. And we'll see that later.
Excellent. Great questions, gang, and thank you for answering all these promptly. Go for it. Yeah, keep going.
Cool. So that's like a run through of this program. And I'm just going to talk about some like brief move concepts that we sort of just went through, but we'll touch on them again. So like some key aspects of move are data ownership. So, data should be stored within the account that owns it, not the account that published the module. This is it's not a hard requirement, but this is a principle that we try to follow. It generally also improves things like parallelism, but it depends also on how you program it. Data flow. So this is what I was talking about, where modules can define exactly what other contracts can do with the things defined in that module. And we'll also talk about type safety. So you can imagine like a coin store, right? Where this is a struct that just holds a bunch of different kinds of coins. You can imagine an approach like this first approach. You can imagine it's like, who owns coins? You could just have a table, which is just like a map of account address to coin. We generally don't prefer this approach. We would rather instead have the coin store just directly on the account of the person that owns the coin. This enables a lot of really nice things. Like you can just go to an Explorer, load up your account, and you can just see all of the resources you have right there. Objects are something that take this concept further, and they do this a little differently, but they're out of scope for the talk. But if you're curious about this concept, I recommend you go learn about objects later. And at the end of the presentation, I'll have some links that talk about this. Here we can see this transfer function. So the transfer is essentially this, like we withdraw, it creates a new coin of some amount, and then we take that coin and we deposit it into the recipient's account. You can see here that the sender takes a signer. So that's saying to send the coins, you need to sign, you need to be the one executing the transaction. Like we need your, essentially your authorization. And from an outside perspective, this signer comes from you using your account's private key to sign a transaction. The recipient, on the other hand, we just accept an address because anyone's happy to receive coins, assuming they've initialized that in advance. The principle we're talking about here is that if you have the functions defined here where fund withdraw, fund deposit, no one else can call that because it's not marked as public. Generally speaking, unless it's unsafe to do so, we recommend making the functions public so that people can compose these functions how they wish. Maybe they want a transfer function that does something different in between the two steps, for example. Maybe it takes some kind of tax or something. If you make withdraw and deposit public, other devs can compose that. And then finally, one thing about Move is that we have type safety in this way. So like, let's say I've got a coin and I've got a coin of a particular type. You can make it distinct in like sort of two different ways. The preferred way is that we support generics and like phantom types. So it's better to have a coin that takes like a phantom type T rather than a coin that takes some kind of GUID or unique string in that way. Generally just because it's more safe from a compilation level. It moves your checks into compile time versus runtime. One call out here is we've been talking a lot about coin lately. If you're actually interested in going and like playing with coins and stuff like that, we recommend you use the fungible asset standard, which is the newer version of coins. And we'll have links to that. And then, yeah, just referring to our original code example, which I've sort of squeezed in a bit, this is a summary of some of the things that this code exemplifies. So like external modules can't destroy or create coin. Therefore, the supply of coin is sort of constrained within the module. Like you'll notice that there's actually no way to create a coin with anything in it from scratch. So you would have to define some kind of minting behavior or something, and you get to control that. U64 can't be below 0, so there's no worrying about forgetting to check those bounds. And yeah, things about the signer that I was talking about earlier, where it restricts who can do what with resources. So like I was saying before, the Aptos framework has a lot of things in it that you might want from the outset. So for example, objects are a way to group resources together so that they can be treated as sort of a single entity on chain, but not an account. So if you've got something else that needs to be modeled together, you can do that with an object. For example, let's say like we have chess on chain and it's a game between me and Nab. Neither of us really own that game per se. We would want to put that game in an object, and then that object would list, here are the two players playing in this game. And that way it becomes easier to model who can do what with the resources of that game. We have a digital asset standard. So this is sort of the equivalent of like ERC20 or 721 on Ethereum. This is just our NFT standard. We've also got, beyond that, a minting standard that provides, well, this is actually non-framework, but we have an opinionated approach to how you can do common minting things like allow lists, mint and reveal, minting phases, things like that. And that's already out of the box. We also have examples for how to build like marketplaces. And then we've got other things like fungible asset. That's like the modern way to do things like coins, but not necessarily just coins. Smart structures like smart table, which is like a map, but hyper parallelizable. Aggregators are the same. Like if you want to mint like a bunch of tokens really fast where they have numbers. Like maybe you want to incentivize people to get in early. It's like my token number one. Aggregators enable you to do that in like a very parallelizable way, rather than being bottlenecked on that one counter, which in most other blockchains would force your minting to become sequential. And recently we unveiled on-chain randomness. So we have verifiable, unbiasable randomness with like a simple one-phase API. People who are familiar with this, in many other chains, you sort of have to do this in two phases, where you like call a function once saying that I want some randomness, and then in another function, you have to call it later in another transaction to claim that randomness. There's no need to do that with Aptos randomness. You just get it in like a API that's much more akin to a normal programming language. Yeah, I'm going to just breeze through this final section so we can get to some questions. This is just a bunch of other things we're working on. Take a screenshot, 3, 2, 1, moving on. Move and Aptos, I just want to call out, are like developed very closely in hand. So when we're working on Move, for example, we're always making sure we're making use of the parallelism that we've unlocked elsewhere in the stack. And yeah, Move on Aptos is growing, and hopefully you will join the community. There's a lot of Move devs out there, and there's also a lot of demand for Move devs. And we'd love to see you join the ranks. And that's it. So, welcome to Aptos, welcome to Move, and here are some resources. I, in particular, recommend the My First Smart Contract tutorial on Aptos Learn. That's like a great way to get started. Yeah. That's it. Thanks for listening to me.
Excellent. Yeah. I guess for developers who want to start learning Move, I think you mentioned it early on that Rust was the closest parallel, but what do you think the learning curve is to get started with Move? I mean,
yeah. So like I said, like when I started at Aptos, I was a Web3 noob. I'd never written like a dApp or a smart contract before. And even early on, like the Move part of any dApp is honestly the easiest bit. like Move is just like really easy to use. Like the standards they provide already do a lot of the things you want. And like it's very easy to write correct code. With a lot of the new features coming out, a lot of the sort of syntactic gotchas will be going away as well soon. So yeah, I had prior Rust experience. I think if you're coming from Rust in particular, it will feel really, really familiar, especially like the Move semantics versus copy semantics. But yeah, if you're just getting started, I highly recommend checking out Aptos Learn. That's like a great place to go.
Excellent. And yeah, we'll link that to the YouTube description if you haven't already done your QR code scanning here. I guess in terms of portability, is Aptos Move strictly constrained to working in the Aptos ecosystem, or do you guys kind of foresee it being portable and people spinning up their own chains and having that backed by Move as a language?
Yeah, this is already happening actually. Movement Labs is another group building a Move-based L2 on Ethereum. And the variant of Move that they're using is the Aptos variant. Pontum's also building like a really interesting thing called Lumio, which is like a EVM plus Move compatible L2, I believe. Though I'm less familiar with that one. So, and of course there are other variants of Moves out there as well on different layer 1 blockchains.
Cool. Awesome to hear. All right, we can get to some questions in the crowd. Nadav has another great question. So for the API, you talked about randomness, maybe a trivial question, but do oracles work in the same way? I guess, can you call an oracle from a Move smart contract?
So randomness, so for starters, randomness actually isn't oracle based. It's sort of like baked into the consensus protocol, which is why we don't need to do this like two-phase randomness. As for like oracles in general, we don't have generic oracle support at the moment. Like you can obviously build your own oracle, and there are people who do, like Pith and various other DeFi people have built smart contracts where they're constantly calling on-chain functions to supply data. I don't know if this is public or not, but it's just an idea that we've been floating of this essentially, where we would enable like generic HTTP calls within Move, and then all of the validators or some set of the validators would reach out, do consensus on the result, etc. So this is something we're thinking about, but not currently supported.
Cool. Yeah, I think that would be an interesting use case to support. Perhaps a topic of future DevNTell.
Yeah, exactly.
Or great question, Nadev. I guess in terms of the ecosystem itself, like what are some of the most interesting projects or dApps that you've seen people use Aptos Move to create? Like, is there something that or a series of things that have caught your eye? Like, oh, damn, this is pretty cool.
It's too bad. I had slides like this and now they're gone.
Oh,
but
no.
I guess well, the first thing that came to mind is something I worked on. But we did this event last year called Graphio that became quite popular. Essentially, it was like similar to Reddit Place, where it was just like a big canvas but on chain. Unlike Reddit Place, we let people draw like lines and stuff, not just a single pixel. Throughout that, it was like 600,000 or something unique different users came and just like competed for space on this canvas. Like people were trying to draw whatever thing it is that they're interested in, battling on this canvas over the space of like, I think it was 24 hours. I can send you this later. There's like a really cool GIF of the time lapse of the chaos of this canvas. But I really enjoyed it. It felt like it really exemplified like the open nature of the blockchain, and like anyone can come along and draw whatever they want. And like Aptos's parallelism like makes that possible.
Awesome. Yeah, definitely send that over. I'd be interested to see. I guess finally, we provided people these links if they do start or when they do start playing around with Aptos Learn. If they do need help, what are some different ways that they can reach out?
Yeah, so the best place to go is, well, I'll send you the link later so you can share it out. But if you just Google Aptos developer discussions, we have a GitHub repo where we use the discussions feature. That's like the main way we're suggesting people go and like ask questions and get help. There's also the Aptos Discord. There are a bunch of us just like always living in that Discord, helping people out. Shout outs to the developer discussions channel and also the Move language channel. You'll get a lot of good help there, not just from us, but from anyone building in the community. And Twitter, like there's a lot of us who just like live on X, sorry. You can always reach out there and like you'll get some help as well.
Excellent. And to top that off, if people didn't know, we at Developer DAO are actually partnering close with the Aptos folks. So after this DevNTell, next week, I believe, starting on the 16th and the 18th of July at 5 p.m. UTC both, we're going to have 2 in-depth workshops with different community members or different members of the Aptos team. So you're going to be vibing with Billy and learning and deep diving more into the ecosystem and really getting your hands dirty with Aptos here, Aptos Move. And you're going to be wanting to attend those because we have a little writing competition up for grabs. You have 10K up for grabs. So you'll definitely want to RSVP for that. And I've dropped the Luma link in the chat here for folks to be able to sign up with that. So definitely a lot of great learning opportunities and a lot of potential for you to cash in on those learnings if you so choose. So definitely look into that, sign up, as you're not going to want to miss all the great content next week. And with that, I just want to thank you again, Daniel, for coming on the show. Really appreciate you taking the time out of your day to teach us all about Aptos Move. I'm really looking forward to seeing how the members of Developer DAO start to use it and build really cool stuff that maybe potentially down the line you come and show on DevNTell here. But yeah, really appreciate you coming on, man.
Yeah, for sure. Thanks for having me. And if anyone has any further questions, feel free to just like tag me on X. I'm dport_apt, and I'll answer anything you've got. Yeah.
Awesome. Yeah, thank you for doing that. And I guess, yeah, with that, I hope everybody enjoys the rest of their Tuesday or Wednesday, wherever you may be around the world. And recall that this week we do have 2 DevNTells. So this was the first awesome session. We'll have another awesome session on Friday with QE News. And we will see you then. All right, all.
Great.
Have a great one.
Thanks.
Cheers.
Bye.
Bye.